Abhishek, I have changed it. Okay.
Okay, yeah, thanks, ma'am.
Any issue on the like session date or something?
Huh. I have no idea about the last session. So the student is saying that he joined the last session on Friday, but no instructor was there.
Friday.
Yeah,
Yes, ma'am.
last Friday.
But Friday there is a session. Yes.
Yes, ma'am. There was a session. I think it was the same ID. I joined and waited, but it didn't even show anyone. Even my classmates. I was the only person in the meeting.
Okay. 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 Fine. We will note it. Okay. Okay. Fine. Yeah. Thank you. We'll inform it.
Okay, ma'am. I don't know whether the meeting was held or not, or
No,
I
no.
don't know
If
what
there is
happened.
any meeting is held, the YouTube link will be updated later. So if it is not there, then it will be not done. Okay, I will check with the team. No issue. Please
Okay,
attend to
ma'am.
this meeting.
So I also have another issue with submitting the assignments, sir.
Which type of assignments? Theory or the programming
So,
ones?
no, sir, graded that programming thing, sir. The first and last assignment I submitted, and it's showing the time limit has been exceeded. I
Okay, so have you submitted the assignment before the deadline?
Yes, sir. The deadline is today, sir.
Okay, the deadline is today. Just a minute, let me check.
I was able to submit the first and all today. Today only I submitted. I wasn't having any difficulties. No.
You were
Yes, sir.
having?
I wasn't I was able to submit the
Okay, okay, you were able to submit those assignments.
Yes, sir.
Fine.
I submitted on yesterday, sir, but it's showing only for first and last one, first and eighth one.
Okay, okay. Just give me a minute. I'll have to check for the deadlines once again.
Okay, sir.
Is it for week 4?
Yes, sir.
Week 4, the deadline is today. Yeah, you are correct. Uh, would it be possible for you to share your screen and show me what
Yes,
kind of
sir. Sure, sir.
interface do you have? Okay,
Yes,
fine.
sir.
Yeah.
Shall I share it right now, sir?
Yes, yes, please.
Okay, sir.
Yeah, your screen is now visible. Ram, you are on mute.
Sir, is it audible now?
Yes, now you're audible. So see, this is not the deadline error. Instead, it is the programming error. So
Oh,
what it is trying to tell you is that your program is taking too long to execute. That's why it is saying time limit exceeded for the program.
okay, sir.
So you might have ended up creating some infinite loop or a loop that goes up to a number of
Oh,
iterations. Maybe you should look at your code once again and try
okay,
debugging
sir.
it.
So also, I in the sixth question that is graded as one for programming,
Mhm.
it showed 4 out of 4 has been passed, but while I'm submitting, it is showing as 3 out of 5 is passed. But in the screen, The dashboard is showing it 4 out of 4 as passed. Is it okay or is there some any issues?
I think the private test cases, one of the private test cases is failing. So the what I say, the small pop-up that you see on the screen for some small time that shows you the number of private test cases your program has passed. Whereas what you see on the interface is the count of the passing public test cases. So
Yes,
that
sir. The
means,
public test is passed. So
yeah, correct. Your all of your public test cases have been passed, but one of your private test cases is failing. That means you have probably missed out on one of the edge cases.
okay, sir. Thank you, sir.
Uh, okay, so I think we can get started with the today's session. So as you all know, we are into week 4 as of now, and the agenda for today's session, I mean the sessions that we usually have on Sundays, is to discuss the theory assignments for the practice purpose especially. So I am going to do the same for week 4 in the current session. Before we get started with that part, let me know in case anyone is having any other questions from some previous weeks or something. Okay, so I'm
Yes.
assuming no questions.
No questions, sir.
Uh, all right. So may I know how many of you have already gone through the contents of week 4, all the lectures, etc. Especially the lectures part, not the assignments one. Okay, I can see 2 of you. Fine, great. And have you tried attempting the assignments for this week?
Yes,
Sir,
sir.
not the only the practice assignment I have, sir. I have completed. So after this session, I have to solve the graded one.
All right. All right. Okay, great. I think most of you have already completed the practice part. So hopefully we will be having some quality discussions in the today's session. So let me quickly start sharing my screen and let us get started with what we have planned for today. Uh, Please let me know as and when my screen becomes visible to you.
It's visible now, sir.
All right. Thank you. Okay, so I think week 4 is all about programming. The programming has officially been introduced in week 3, and I guess week 4 will entirely be focusing upon different concepts of the programming, probably with loops, conditionals, variables, etc. Fine. So the very first question is based on some conditionals. So it is using a number of if and else blocks, and let us try to find out that what is going to be the output for the given code snippet here in the first question. But before that, let me discuss one important aspect of writing conditionals. I believe that this notion is common across the programming languages and not specific to C, but maybe a few of the languages, you know, might not be having the similar kind of notion. But let us firstly talk about C, and the rest of the languages, let's keep them apart as of now. So whenever you create a condition, so at this point of time, I am assuming that since all of you have already watched the lectures for week 4, so you must be knowing what actually conditionals are. Conditionals are simply the conditions that you check, uh, to basically evaluate something in your program. Let's say if the rain is going to happen today, I am going to take the umbrella with me, else I am not going to be taking umbrella with me. So these type of conditions can be applied in programming as well, just like we apply them in real life. For example, the example that I just took, there could be various or numerous examples that we could take with respect to conditionals. Right? For example, if your marks are between 90 and 100, you will get S grade, you will get A grade, or something like that. Okay. So these type of conditionals itself are applied in programming, and the way or the syntax, the way they are implemented is we use this keyword called if. This is a keyword. Since it's a keyword, that means you cannot use it as an identifier. Identifier, that means you cannot use it as your variable name. You cannot use it as your function name. It already has a predefined meaning, and you cannot overwrite that. So you basically write if. After that, you have these pair of round brackets, and then you specify what condition you will be evaluating here. This is a condition part, and it could be anything. What all matters here is that whatever you are writing here should evaluate to true or false. That's all. If whatever expression you have written here is getting evaluated to true or false, you are good to go, and that is going to be a valid thing to be put inside the if block. And if this condition is true, then you basically use these curly braces and you define what all steps need to be taken in case the condition evaluates to true. You could write number of steps, number of statements here. And similarly, if this condition is not true, you could either do else. In else, you can again use curly braces, and then you can specify what all statements will come under the scope of this particular condition. That means else part is going to be covering all those cases where if is not covered. Right? So if this condition evaluates to false, it will definitely go into the else part. But we also have a concept of else, or I would say, yeah, if else later. What you can do is after specifying a condition, if this condition is not met, of course, you have an option of putting an else here, but else kind of takes away some flexibility from you because it might happen that if one condition is not true, you might want to check for two more conditions. And those two more conditions have certain different steps to be taken. And that flexibility is taken away if you directly use else. Of course, what you could do is you could write else, and inside else you can again use one if and else. Here you can again check whatever condition you would want to check, and then you can again apply else. But this is not a, I would say, good syntax. Instead, what you should do is you should write write it here itself and saying else if, and then you specify another condition that you would be looking for. And if this condition evaluates to true, then you will be executing these number of statements. You can again have one more else if. You can write one more condition here, define the steps that you would be doing in case this condition evaluates to true. And after that, you have else. I mean, it is of course optional for you, but in case none of the condition is getting true here, then you can of course put a else statement at the last, specifying that what to do in case none of the conditions is being evaluated to true. Right? So this is how you can basically create if else letter. This syntax could also be used in order to create if and else letter, but that would not be a cleaner syntax. This is a cleaner syntax. Easy to read, easy to execute, and of course easy for readability. Now, the concept or the notion that I was talking about is if condition. And what I want to do here is I just want to printf and say correct. Now this condition could be anything that I have written here. I have not specified that, but you could assume it to be anything, right? Which can either evaluate to true or false. What can I do is, let's say if I have just one statement as part of this condition, then what I can do is I can omit these curly braces. That means this code is equivalent to if condition printf, and then you can write correct, right, like this. So since we had just one statement here under the scope of this given condition, we omitted these curly braces. But at the same time, let's say if there would have been more statements here, can someone guess what would happen if, let's say, there are some more statements that you want to put under the scope of this particular condition and you forgot to put these curly braces or you omitted these curly braces? What do you think what will happen? Let's say there is one more printf that says ABC. Let's just assume there are two. And you want both of these statements to be only get executed when this condition is true. But in case you omitted these curly braces, what do you think what can happen in this case?
So even if the condition is false, ABC will get printed.
Exactly. So this is not a part of this condition anymore, and this will be executed in every case. Doesn't matter, or you are not really concerned about the output of this condition as of now. This will always be executed, right? So Please make sure that if you have a practice of omitting these curly braces in case you have just one statement under the scope of your condition, please use that carefully. Otherwise, sometimes you might end up missing these curly braces for some more than one statements too. So yeah, this is one of the common notion that we follow across the programming languages. Yeah. All right. So the question that we were referring to is based on a similar concept. So if you look at it, let me clear the paint and then let us do it. So we have three variables x1, y1, and z0. So x is 1, y is 1, and z is 0. And then you have if y equals to x less than 0, in that case you are assigning z to 1, and if y is equals to 0, then you are assigning z to 2. Is it else if of what? It's else if. Okay. And then you have else z equals to 3. At the last, you have to print y and z. You have to find out what will be the final values of y and z. Now, let's come here and let's try to first evaluate that what this statement or what this expression is actually trying to do. Now, you can see that if and within these round brackets, as I told you before, it is supposed to be an expression that is either going to be yielding a true value or a false value, right? But in the name of the expression, what we have gotten is we have gotten this y equals to x less than 0. Right? Now we have to evaluate this expression and find out whether it is going to be yielding a true or a false value. So let us try to break down this expression. And when we start breaking this particular expression, the very first thing that we will be trying to evaluate is this x less than 0. Right? Because since we are using brackets here, and brackets almost or every time have the highest priority. So whatever comes with bracket, you have to evaluate that first. So we will be evaluating this condition first, that is x less than 0. What do you think? Is this condition true? X less than 0?
False.
This is a false statement. And since this is a false statement, what will it be yielding? Will it be yielding 1 or 0?
0, sir.
It will be yielding 0. So this is the expression that we have gotten. Now, we have to find out that what type of value this expression will be yielding. That is y equals to 0. Will it be yielding a true value or a false value? What do you think?
False value, sir.
It will be yielding a false value because what you are trying to do here is you are trying to assign this y with the value 0. And whatever value that you are assigning will be the actual return value from this expression. That means if you are assigning 0 to this y, the returning value from this expression is going to be 0. Whereas if you would be returning the value 5, the returning value from this expression is going to be 5. But in addition to that, this is doing one more thing. This is also overwriting the value of y. Y was previously 1 and now it has overwritten it to what? It has overwritten it to 0, right? So in that case, y has become 0. But since this condition has evaluated to false, this part, this first statement or this first if condition will not be executed. If this is not executed, we will go to the next else if condition part, right? To check if this might be true. Whereas if this itself had been correct, we wouldn't have gone to the second part because we knew that the first condition itself has become correct. That means none of the other conditions in the trail will never be executed, right? Because the first condition itself has given you the positive outcome. Now, since that we have gotten a negative result here, we will move to the next part and we will check else if y equals to 0. What do you think? Is this a true statement or a true expression or a false expression?
It is true, sir.
It is true because remember the previous expression or the previous statement has overwritten the value of y from 1 to 0. Since it has become 0, this condition becomes true. That means y is actually equals to 0. And since this condition is true, whatever you have written here will be executed. Why didn't we execute z equals to 1? Because this condition was false. But now that we know that this condition has become true, we have to execute this z equals to 2 part. And since we have to execute it, we have to override the value of z from 0 to 2. Right? And now that we know that this condition has become true, we won't even go to the else part, because else part will never get executed if any one of the above conditions has become true. And I guess after at the last we had to find out the final values of y and z. So you can see the value y has a value of 0 and z has a value of 2. So it is first trying to print the value of y and then z. So 0 and 2 is going to be the answer. That is the second option. Is this understood to all?
Yes, sir.
All right. Okay, so let's look at the next question that we have. So we have two variables, I and j, both have value 0, and then we have a loop here. Okay. So we have I equals to 0, we have j equals to 0, we have a loop here. So it says I less than 5, then j plus equals to plus plus I. So see, this is using a shorthand for assignment operator. In the last session, I also discussed about this, that if you are using plus equals to, let's say a plus equals to b, this is equivalent to a equals to a plus b, right? And this is prefix increment, right? That means the increment will happen first, and after that, the assignment will happen. And after that, you are simply trying to find out the value of I and j. That's it. Okay, let's try to see. Well, this was just an example, so I'm just cutting it down here. So we have I and j, both are initialized to 0, I guess. Yes, they are. And what we are doing is we are running this loop. Now, loop is something that keeps on executing until a certain condition becomes wrong. So till this condition becomes wrong, whatever you have written here will keep on executing. So the very first condition for us is I less than 5. And at this point, I is having the value 0, and of course, which is less than 5. Since this condition is true, what we will be doing is we will be doing j equals to j plus plus I. I have simplified this expression for you so that it becomes easier for you to work work on this. So can you tell me what will be the new value of j and I after executing this? Can anyone tell me what will be the updated values of I and j after executing this expression?
So I think initially I and I and j will be 0. So
Yeah.
j is equal to 0 plus 1, that is 0 plus 1, which is 1. First it will.
Okay, but you can see that this I is also getting incremented because we are using prefix increment here.
Yes, sir.
Right. So firstly, the very first thing that will be incremented is I. So plus plus I will increment its value by 1. The initial value of I was 0, so it has become 1. Right. Now that I has become 1, you are adding it with the value of j. What is the value of j? The value of j is 0. So you are adding 0 plus 1, 0 plus 1, and ultimately you are getting 1. So the value of j is also getting updated to 1. I hope this was j. No, this is not. Fine. So after executing this expression, you have gotten the value of I to be 1 and j to be 1 as well. Is that understood?
Yes, sir.
Okay. Going on to the next iteration. This time we have 1 less than 5, which is of course true because 1 is less than 5. And if this is true, we will have to execute this same expression once again. This time we know j is having the value 1 and I will be incremented and I will get the value 2. So I has become 2 and j will become 3 this time because 1 plus 2 is equals to 3. Sorry, 1 plus 2 equals to 3. Next time we'll move again. We will check if 2 is less than 5, which is of course true. Again we will do this j plus plus I. What is the current value of j? That is 3. What is the current value of I after getting incremented by 1? It will be 3, right? Current value is 2. After incrementing it by 1, it becomes 3. So 3 plus 3 becomes what? 3 plus 3 becomes 6. So j becomes 6. Now again we say that 3 is less than 5 as well. We have to execute the same expression once again. This time j is having the value 6 and I will be incremented by 1, so it will become 4. So I will become 4 and j will become 10. We will come again here. We will say 4 is less than 5. We will execute it once again. Here, this time the current value of j is 10. The value of I after getting incremented by 1 becomes 5. So it becomes 15 and I becomes 5. It becomes 15. And after I has become 5, then this condition also becomes wrong. And as soon as this condition becomes wrong, this loop is terminated. And if this loop is terminated, what happens next? We simply print the value of I and j. So can you tell me what will be the values of I and j now?
5 and 15.
5 and 15. Yeah, correct. Again, the second option. Yes. All right, so this is how this loop works. This is how you have to keep on updating the values, and this is how you can even do the dry run yourself. The process that I am currently, doing here, this is known as dry run. Dry run means you are trying to, break down each and every iteration of a loop, let's say on a paper or on some other material, so that it becomes easier for you to understand that how the program is actually getting executed or how the flow is actually going. So this is actually the flow of the program or the steps that the compiler would be taking internally that we are not able to see, right? All these things. So I hope this thing is understood.
Yes, sir.
Yes, sir.
All right. So yeah, we have ticked on the correct answer. Fine. So this is the next question. So here we have three variables I, j, and k. Both are, all are 0. This is 0, this is 0, this is 0. And then we have while I less than 5. And here we have two statements. One is j plus equals to plus plus I. The second statement is k plus equals to j. K plus equals to j. Remember, both of these statements come under the scope of this loop. That means if this condition is true, they both will be executed again and again. Let's see, the condition is 0 less than 5. That means I less than 5, which is of course true. And since this condition is true, let me simplify this expression. It becomes j equals to j plus 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 I. In that case, what is the current value of j? It is 0. What is the current value of I after getting incremented by 1? It is 1. So 0 plus 1 is what? 1. That means the value of j has also become 1. And after executing this, we have to execute k equals to k plus j. So what is the current value of k? It is 0. What is the current value of j? It is 1. So the current value of k has also been updated to 1. So after the first iteration, everything has been updated to 1. I, j as well as k. Are you getting it?
Yes, sir.
Fine. We'll move to the next iteration where the value of I has been updated to 1. So we'll check for 1 less than 5, which is of course true. So we will execute the same statements once again. The current value of j this time is 1. The current value of I after getting incremented by 1 is 2. So 1 plus 2 becomes 3. That means j becomes 3. Right. And if j becomes 3, then the current value of k is of course 1. The j is 3, so k becomes 4. So this way, k has become 4 because you are adding up the value of itself, that is k, and j. So k is 1, whereas j is 3. So after getting all of this, we have said that the k has now been incremented to 4, or k has been overwritten with the new value of 4. The next iteration is 2 less than 5. Here we'll again execute the same part. J this time has got the value 3, and I will be incremented once again, so it will become 6. I becomes 3, j becomes 6. What will be the new value of k? It will be 10. Right? We move on to the next iteration. J equals to j plus I. The current value of j is 6. The current value of I is, after getting incremented, it becomes 4 and j becomes 10. So 6 plus 4, it becomes 10. K was already 10 and this time j has also become 10, so it becomes 20. So k has become 20. Now the last iteration where 4 is less than 5, we will again do the same things. This time the current value of j is 10. The current value of I will become 5 and j will ultimately become 15. Right? Since j has become 15, it will also affect the value of k. So the current value of k is 20. The current value of j is 15. It becomes 35. So the current value of k becomes 35. And after that, when you come and say 5 is less than 5, this condition becomes wrong and you exit out of this loop. As soon as you exit out of this loop, you are required to print the final values of I, j, and k. The value of I is 5, j is 15, and k is 35. So 5, 15, 35 is what you would got. Are you getting this?
Yes, sir.
Okay, fine. Okay, so maybe this does not require iterations. Maybe you would be able to do it within your minds. So the question is, how many times will the condition specified in the while loop be checked if the program is executed? Can someone answer this question?
So it will be true till 4 is lesser than 5, so the answer will be 4.
It
No,
is.
it will be 6 times, sir.
Let me clarify this question once again. So it is asking that this condition that you have specified in the while loop, how many times will this be checked? It is not about what
Sir,
will be
it
the
will be
future.
6 because first it will check when it's 0, then once when it's 1, then again when it's 2, 3, 4, and then 5 again.
Exactly. So as you are seeing
Oh,
here, whatever iterations that we have done, we were starting with the initial value of I to be 0, and we were going all the way up to I less than 5, right? And till that point, how many iterations or how many conditions were we checking? Can someone tell me? This is the first condition check. This is the second condition check. This is the third. This is the fourth. This is the fifth. And this is the sixth, right? Because when the condition is getting wrong, this is also getting checked, right? Though it is becoming wrong, so the loop part is not getting executed, but the condition is being checked. So that is why when the initial value is 0 and your condition is I less than 5, we will, or this condition will be checked for 6 times. 1, 2, 3, 4, 5, and 6. Are you all getting this?
yes, sir. Now only it's clear.
Okay, great. Fine. So as you can see, the I is also getting incremented and we are not using curly braces because there is just one statement as part of this code. So that's why we can omit those curly braces too. So the correct answer would be 6. All right. So which of the following loop implementations will lead to the creation of an infinite loop in C language? What do you think? Which all of these implementations will result in an infinite loop? See, this is definitely an infinite loop because when you are saying while 1, I mean, whatever your condition part is, you are saying 1. 1 is a value that will always evaluate to 2. And if this is getting evaluated to true, that means this will never become wrong. If this will never become wrong, this will end up creating an infinite loop. So this is definitely an infinite loop. The second infinite loop is, can someone guess? Can anyone guess the second infinite loop?
Sir, the one above it also will be infinite only, no, sir. Because I will never become less than 0.
Okay. So the concept of 2's complement will be applied here. So assuming that I is 1 and you are considering the condition to be true, if I is greater than 0, of course you are starting with 1, so whatever values it will go up to will always be greater than 0, but there will be a point when the size, I mean the value, the positive value of the integers will run out. And if those positive values are running out, the next value, whenever it will be getting incremented to, will actually be a negative value inside the computer representation, right? For example, if we are talking about, say, 32-bit. So in 32-bit, we say, or I think we are talking about 64-bit architecture, and we are saying that we are considering the size of integer to be 4 bytes, right? So can someone tell me, if the size of an integer is 4 bytes, how many numbers can you represent with 4 bytes?
So is it 32 bits?
Yeah, of course, 4 bytes are equivalent to 32 bits. So with 32 bits, how many numbers can you represent? Just give it a guess. Maybe you have already done it in week 2, I guess. Okay, so it will be somewhere around 2 power 32, and the similar thing is going to be true for negative numbers as well, where it will be 2 minus 2 power 32 minus 1 or something. I think no, not here. I guess here. Okay, so you can go all the way up to 2 power 32 minus 1. This is going to be the maximum positive number that you can represent with 4 bytes, and the smallest negative number that you can represent is going to be minus 2 power 32. Now, the case that I'm referring to here is assuming that the maximum positive number that you want to represent is 65,535. This is the maximum number that you can represent in positive notation. So as soon as you make an increment of 1 to it, the number becomes 536. And as soon as it becomes 536, it will be having a representation of a negative number, probably minus whatever the number comes up, maybe I don't exactly remember. It will either be, okay, let's forget about that. Anyways, the maximum number that you can represent is going to be this. And as soon as you make an increment of 1, now this becomes a negative number because of 2's complement notation that all the modern compiler uses these days. Right? So as soon as this becomes negative, coming on to this question once again, as soon as the value of I becomes negative, will this condition still be true?
No, sir. The loop gets terminated.
Exactly. At that point of time, the loop will get terminated. And that is why this is not a correct option.
So what about first one, sir? Because no end value is given.
This
So
is
will it?
also an example of an infinite loop because the syntax of using for loop is, so whenever you use for loop, the very first thing you do is you do initialization part. Right? The next thing you specify is the condition that is going to watch whether the loop has to keep on executing the body or not. And the third part is you do increment or decrement. Right? So there is nothing mandatory in this for loop syntax except these two semicolons that you are seeing. Well, this might look funny, but yes, that's a true statement. Nothing here is actually mandatory for you to write. You can omit this initialization part, you can omit this condition part, you can omit this increment decrement part. But in order to make a for loop a valid syntax, you will have to only mandatorily use these two semicolons. That means if you write these two, this is a perfectly valid for loop in C language as well as C++, but this is actually an infinite loop. Right? Infinite loop because this does not have a condition. And if it does not have a condition, it will go on forever. Right? We can even execute that. Maybe I can open a online compiler that can do that for us. Right, so I would say for all I am gonna do is this. And since I am not using curly braces, so this statement will be considered under the scope of this for loop. So if I click on run, you can see that it is keep on getting executed. See how many times we are getting this try programmers.pro, whatever the string is. I can keep on scrolling here. And after that, it is saying that the code exited with errors. The reason is because the stack size that is generally allocated to your program or your compiler, that will actually be exhausted, because you have made so many calls that there is no memory left inside your stack in order to execute the further statements. And that is why after some point of time, your program will actually crash whenever you are trying to implement a infinite loop. Okay, so that is why this is also an implementation that could run into an infinite loop notation. Are you getting it?
Yes, sir.
Are you getting it, guys?
Yes, sir.
All right. So, yeah, I think these are the only two options which I guess would make an infinite loop, the first option and the fourth option. Second option, I hope all of you understand that this is only going to run for 4 times, that's all. And this, as we discussed, as soon as the first increment happens after the maximum value of positive notation has reached, this condition will also become wrong. And this is, of course, an infinite loop because the condition will always evaluate to true here, which is 1. Okay, fine. So the next question is, uh, you have to find out whether the statement specified here is true or false. A switch statement must have a default case to avoid a compilation error. How many of you have worked with switch?
So it's confusing, so I couldn't understand the concept properly, so I didn't try till now.
Okay. So let me just draw a simple diagram. Just give me a minute. Sorry for the disturbance. Uh, so see, the way we use switch blocks is we use this switch keyword, and then we specify a value or probably a variable that can have certain values. Let's say I am specifying a variable to be num, right? And depending upon the value of num, I am going to be specifying certain cases. Let's say if the value of num is going to be 0, I will be doing something. If the value of this num is 1, I will be doing something. If the value of this num is 2, I will be doing something. But let's say in some unforeseen circumstances, the value of this num is neither 0, 1, or 2. In that case, how do you do, or how do you basically take care of these things where the value of num is not matching any of the cases that you have specified here? That is the case, or that is the special case where you would be using default. So default is going to be executed when none of the cases are actually matching. And here you can specify whatever actions you would want to take in case this num value is not matching with any of the cases here. So the question that is trying to ask you there is that is it mandatory for you to use this default block always with a switch block? This is what the question is trying to ask. What do you think? Have you understood the question now?
Yes, sir. Thank you, sir.
Yeah. So what do you think? Whether the statement is true or false? Anyone?
So it's not mandatory. It's mandatory only when it's when the condition is not satisfying any of the cases. So it might
Uh,
be false.
Yes, the statement is definitely false, but I would just like to clarify on what you just said. So I guess both of your statements were contradicting each other. So see, it depends on the programmer's choice whether he or she wants to have a default case in his or her switch implementation or not. It is absolutely fine if you omit this default notation completely from your switch case. That is completely fine, absolutely fine, no issues with that. So it is going to be not mandatory in any case. Of course, it depends on the preferences. A good programmer would always want to have a default case just to find out in case the switch or the program has run into some error because the value of whatever variable that you would have specified here is didn't match with any of the cases that you planned for. So in that case, you would be having this default block. But remember, this is not a mandation. This is not necessary. This is a good practice to have it, but this is not mandatory. This is not going to cause you compilation errors if you completely omit this. Is this understood?
Yes, sir.
Fine. So this is going to be a false statement. Okay. So again, we have gotten this question where we are required to find out the output. I guess we have already done 3 or 4 types of such question. So maybe I would leave it on to you and you could do it for your own practice. Of course, the concept is similar. There is nothing fancy that is happening in this particular question. Right. So I would be skipping this question as of now. All right. So coming on to this question, maybe let us try solving this question. Okay, so it has 2 variables, I and j. Okay, it has I and it has j. It has written a loop where I is equals to 10,000, j is equals to 1. Then I is greater than 0. Sorry, it is just greater than 0. And I divide by equals to j. And j multiply equals to 10. Just take this eraser and I don't know which pen I had earlier. This is not definitely.
Sir, but for loop, could we just give multiple statements or
Yes,
multiple
I'm coming on to
conditions
that
like?
part. Yep, coming on to that part only.
Okay, sir.
Yeah, fine. So yeah, the important thing that you are noticing here is we are also using commas. We are also using commas, but the main thing that you should be pointing out here is that we are only using 2 semicolons. One semicolon is this, and second semicolon is this, right? Only 2 semicolons. Because the for loop syntax says that you cannot use less than 2 semicolons, more than 2 semicolons. You always have to exactly use 2 semicolons. But what if you want to work with multiple variables? Because generally when we use for loop, we make one of our variables as an iteration variable where we specify what is going to be its initial value. We specify what should be the value range should be in order to make the condition true or false. And after that, we specify how that variable value should change. Should it get decremented or incremented? If so, then how you would want to do that. Generally, this is how you would work with for loop. But if you want to work with multiple values, for example, here, you are of course working with I, but you are also working with j here, right? So this is how you can do that. You can run loop for 2 variables with the same for loop, with the same for loop syntax by using these commas. Here you specified what should be the initial value of I. Now, since you want to work with another variable, you cannot use semicolon. You will do the initialization for the other variable by putting a comma here. You put a comma, you specify the initialization for the other variable. Then you have a semicolon. Semicolon means you are going to be putting the condition now. The condition was I greater than equals to 0. If you would have wanted, you could have also written some condition with j. That is not the case as of now, but this could also be done. You have put one more semicolon here. That means now you are going to be controlling the values of your variable within the for loop, and that is how you are doing it. I divide by equals to j, and you are putting a comma, and you are also controlling the value of j as well. So this time, this for loop is working with two variables, I as well as j, but the syntax says you can only use two semicolons. So that's why we are using commas here. The notation is
So
going to be same. That means if you are using comma before the first semicolon, this is the statement that will only get executed at the initial time when the loop is getting initialized. Whatever you have written after the first semicolon will always be executed after executing the loop body, and whatever you have written after the second semicolon will always be executed after the loop body has been executed, just like the condition and the incrementing and decrementing part works in a normal form. Yes, please.
so instead of using two for loops, we can use like this, sir. Is
Of
it
course,
like
you
that?
can do that. If that is satisfying your use case, you could, of course, do that.
Okay, sir.
All right. So now let us try to understand that how this loop is working, or finally we have to find out the values of j and I. That's all. So let's see. Okay. Uh, so we have the value of I to be 10,000, j is 1. We will be checking the whether the I is having the value greater than 0. Of course, it has. Since it has the value greater than 0, what this loop is doing? This loop is simply printing the value of j and I. Okay. So we have to print j and I. So I will be, say, printing the output where, uh, okay, let me print the output here. Okay. Or let's say here. So initialized, yes, the value is greater than 0. So in that case, the value of j that you will be printing is going to be 1, right? I think we are printing j first or I first. We are printing j first. Okay. So firstly, the value of j is 1 and the value of I is 10,000. I'm using these commas just to make it more readable for us. It is not a part of the program as such. Okay. Now, after executing it, we will again come here and check whether the condition is still true. Of course, the value of I is still 10,000, which is greater than 0. So this condition is true. Now we will execute this part, right? And this part says that you have to make I equals to I divided by j. So what is the current value of I? I is 10,000. What is the current value of j? It is 1. So ultimately, it will remain the same. So I is still 10,000. And j has now become what? J equals to j multiplied 10. Current value of j is 1. You are multiplying it with 10. It becomes 10. So for the next iteration, the value of j is still, sorry, the value of j has become 10, but the value of I is still the same. That is 10,000. Are you getting what I'm trying to say here?
Yes, sir.
Okay. Now, after this is done, you will again go to the condition part. The condition is still true. You would again execute these incrementing or decrementing parts. So here, I will become what? I will become 10,000 divided by what? 10. What will be the new value for I? It will be 1,000. And j will become 10 multiplied 10. It will become 100. So the new value of I is 1,000 and the new value of j is 100. So you print the new value of j, which is 100. The value of I is 1,000. Again, you come back to the condition part. I is still greater than 0. Since I is greater than 0, you again said that the current value of I is 1,000. You divide it by 10, it becomes 100. And j, the current value is 100. You multiply it with 10, it becomes 1,000. So the current value of j is 1,000 and the current value of I is 100. Okay. You again come back here. Sorry, I think I have done a mistake here. Sorry, I will have to go back. So like I didn't consider the current values of j. Or let me do one thing. Fine. Okay. Okay, I also have to get it. Let's start it right from the beginning. Okay. So the current value of j is going to be what? J is going to be 1 and I is going to be 10,000, right? When the condition is still true, the value of I will still remain 10,000, whereas Z will become 10. So Z will become 10, I will still remain 10,000. The next time, I, which is having the value 10,000, will be divided by 10. So it will become what? It will become 1,000, whereas J will become 10 into 10, 100. So next time, J will become 100 and I will become 1,000, right? And now, next time, when I is 1,000 and it will be divided by the value of J, which is actually 100. So what will happen is it will become what? It will become 10. And J will become what? 100 into 10. It will become 1,000. So J will become 1,000 and I will become 10. After that, again, the condition is still true because I is 10, which is of course greater than 0. So I will be 10 divided by 1,000. Of course, will be a value 0.001 or 0.001, and J will become what? 1,000 multiplied by 10, it will become 10,000. So after that, J will become 10,000 and I will become what? Okay, but the question is, when we have said that the current value of I is this, so as soon as the condition passes here, okay, which is I of course is greater than 0, so this time the value of I becomes something and J becomes something. Okay, so again I have messed up this part. The actual logic is that firstly the increment and the decrement part actually happens, and after that the condition is checked. So that is why we will stop here itself. This part won't even cover. Why? Because when we have printed the value of J is 1 and I is 10,000, next time when you will be incrementing and decrementing the value of I and J, I will remain 10,000, J will become 10. And after that, the condition will be checked. So there, I is still 10,000. So 10,000 is greater than 0. So here you have said J is 10 and I is 10,000. That's fine. You move to the next step. Next step is you again decrement or divide the value of I by the correct value of J. So 10,000 divided by 100. When you did that, sorry, it was not 100, it was 10. So when you did that, the value of I came up to be 1,000 and J become 100 this time. And I, the value of 1,000 is of course greater than 0. So you will come inside the loop body and you will print the value of J, which is 100, and I, which is 1,000 now. Then you will again go to this part here, 1,000 divided by 100, it becomes 10, which is of course greater than 0, and J will become 1,000 in this case. So I has become 10 and J has become 1,000. And this is what we are printing here. Now, next time when you will come here again, where you will say that the current value of I, which is 10, and you are dividing it by the value of 1,000. So 10 divided by 1,000, you will get the output to be 0.001, right? And J will actually become 10,000. But when you will come here and you will check that if I is greater than 0, but remember we are working with integers only. So what I have written here is 0.001. This will be the case when you are working with floats, right? But we are only working with integers here. And since we are working with integers, what do you think 10 by 1,000 is going to yield? This operation. Can anyone tell me what will 10 divided by 1,000 will yield? When you are working with integers alone?
So it will give us 0. And it will omit
Exactly, it is going to be 0 because it will not consider the decimal part at all. And when the value of I has become 0, do you think this condition will still hold true? That is I greater than 0?
No, sir, it will become false.
So this condition will become false. And as soon as this condition becomes false, we will stop here and we will not print the value of J and I anymore. So this is the output that we will actually get. 1, 10,000, 10, 10,000, 100,000, 1,000, 10. So, I think this is the answer. 1, 10,000, 10, 10,000, 100,000, 100,000, so, and 1,000. Is it 10? Yes, it is 10. Yeah, so C is going to be the answer. I think one thing that we can note here is the multiplication of both of these values is always 10,000. It is 10,000 here. No, here it is false. Anyways, that is fine. So this is the output that we are getting after executing this for loop here. So did you all understand? We of course went through a lot of uh, back and forth here due to some confusions, but finally we have gotten a correct answer, which is this. Is this okay for all?
Yes, sir.
All right. So I think we are currently running out of time. So let me see if there are some theory-based questions. Maybe we can take them, and the programming-based questions. Maybe you can try them yourself, and we can discuss those in the next session in case you are having difficulties. Okay. So this is a true and false statement. It says an if statement must have an else block to avoid a compilation error. But do you think that if you are using a if, is it mandatory for you to use an else?
Sir, no, sir.
Of course, it is not true. So this statement is a false statement. Okay, flowchart. All right, so these are some good questions. Maybe I'll discuss these in the next sessions whenever it will happen. So maybe till then, you can try to find out the values for especially 13th, 14th question. These are very good questions based on the use cases of for and while. Of course, every program that you are writing in C is probably possible to implement it in both for as well as while loop, but there are very general notations about how and when you should be using for and while loops. On a very high level, if I would like to tell you is for loops are generally used or generally considered when you actually know that how many times the iteration is going to happen. For example, here you are specifying what is the initial value of I, you are specifying what is going to be the condition, uh, you know, due to which the loop body will keep on executing, and how you will be controlling the value of the variable that you are working with. So here you generally have a better idea about how many times or how many iterations will your loop be going through. Whereas while is generally considered in scenarios where you are unsure about the number of iterations. For example, we generally write, say, I does not become equals to true or something like that. Like I'm just taking an example, need not be the exactly same, or you can say while n is greater than 0. This is generally considered when the number of iterations, the exact number of iterations are not known before you are actually writing the loop. So I guess these will be the options that you will get for these two questions. Which of the following loop is preferred for computing the factorial of a number? Which of the following loop is preferred for finding whether a number is palindrome or not? See, when you are computing the factorial of a number, you know exactly how many iterations your program will require, because you will start with 2 and you will go all the way up to the number that you want to find the factorial for. Or you will start with 1 depending upon how you would like to write the program. Whereas in case of palindrome, you don't know how many times your loop has to be executed, right? Because you will have to iterate the entire number, and you have to find out that how many digits are there. You have to reverse those digits, and then you will have to find out. So in case of factorial, you would be preferably be using for loop, whereas in case of palindrome, you would preferably be using while. This is again a general notation. This is not something that is written on stone. Of course, it is absolutely possible, probably for every program, for every logic, to be implemented in both while as well as for loop. It's just that the preference where you would want to use what. That's all. All right. So that's all from my end for the today's session. Please let me know if you have any questions to be asked as of now.
Sir, I have a question, but it's not related to the subject. Is it fine, sir?
Huh, fine. Okay, let me stop the recording as well as. Okay, let's keep on the recording. Yeah, fine.
Sir, so where should I contact if I'm not able to join in a meeting or something like that, sir? Any trouble
Uh,
issues?
okay, so what you're saying is you want to seek some help apart from joining these sessions, right?
Yes, sir.
So there is this email, and you can write to that email, and that email will actually be redirected to the concerned person, and the concerned person will be in touch with you. I guess the email is support yes or something. Let me quickly verify. I think I have shared it in the last session as well, if I'm not wrong. Yes.
Yes, sir. I have taken a screenshot, but it wasn't available. Some memories were lost in the computer.
I have sent it again.
Thank you, sir. I am noting it down.
All right, sure. Is there anything else?
No, sir.
All right. Okay, so in case there is nothing else, all right. So I guess this is a good time to end the session for today. So hopefully you would have got to learn something new in the today's session, and we'll see you in the next session once again. Till then, bye bye and take care.
Thank you, sir.
Thank you, sir.